Alright, gonna hit this daily leak code for some practice, and just because I feel like I'm getting washed at leak code. Okay, I guess I already did this problem before. Let's see the minimum number of increments on subarrays to form a target array. You are given an integer array target. You have an integer array initial on the same size as target with all elements initially 0. Okay, so I'll start inputs and outputs here. You have a target, which is an array of nums, or integers, I mean. And you want to get to it by an array of zeros, from an array of zeros. And in one operation, you can choose any subarray and increment the value by 1. Okay, so choose subarray and inc all by 1. And okay, test cases are shown as valid. Pretty normal constraints, so tells me it has to be probably like O of n or n log n. In this case, the target is this array. Okay, well, how would we do this? If we were to follow by the rules, we would make all of these 1, we would make all of these 2, and we would make this one 3. So we're choosing the biggest subarray at first, and it's just gonna take, how much will it take? 3 operations. But one thing to notice, I guess, is the operations that we took. I want to actually. We started with all of these, right? And then we went to the inner one, and then we went finally to the one in the center. One thing I have a question on is, what if it was like alternating pattern, right? Like 1, 2, 1, 2, 1, 2. You would be able to do all of these as 1s, but then you would have to, in one operation, like in one swoop, then you'd have to make these ones individually 2, which would be like 3 more operations. So what does that mean here? When you go from a smaller number to a bigger number, that's automatically an extra operation you would potentially have to do. So that means if you go from 1 to 2, you automatically have to consider that as an operation. But also, if you go from 2 to 1, is that another operation? In this case, it's not, because this 1 matches with this 1, but then you go to a 2 again, then it would be another operation. But what if the case was like this, where it was like 1, 2, 1, 1, 1, 1, 1? This should only be 2 operations. What about this case of 3, 1, 1, 2? All of these will be 1 operation to the color 1s. And then this is automatically 2 more operations. And then another operation, right? So it would be 4 operations. So in other words, when you're bigger than the last element that you applied operations to, you implicitly have to do that many operations. But if you start decrementing, or if you make any change at all, the operation that you have to do is gonna be like the delta between these two, right? Would that make sense? So by my logic, there's technically a 0 in front of the array. Okay, there's technically a 0 here. We're bigger than 0 by 3, so our delta is 3. That's automatically 3 operations we have to do. Now, there's a difference between 2 here, but since we are less than 3, we could just combine these as one operation. So this one is fine. Now, what about this one? Well, it'll just be combined with this one right here. So that's basically saying we're going to pick all of these ones and combine them with one operation from this index, which will make like 1, 1, 1. And then now we're at a 2 though. At this point we can't just combine the operation because it would make all of these 2. So what does that mean? That means that we have to use another operation because we're basically splitting the subarray off. So yeah, it would be 4 because your delta is gonna be 1. And I'm sure that's what happens over here, where you pick all of these. Okay, and you did have to do this one by itself and then do the 3 2 times. How'd this look for the last problem? There's technically a 0 here. So, okay, we have to have 3 operations for sure. We're not going to count this one because it's less than 3, so it can just be part of that, like, suite. We'll do it all in one. Now 5 though, this is more than the 1 right here, so it would have to get cut off. You can't just include it in your subarray, or you can once, but after that you're gonna have to put hella operations yourself, which is 4. Now 4 is less than this, so we're gonna say yeah, we just did all 4 of those in one suite. 2 is less than this, so we'll say we did 2 in one suite, and we'll have 7. So the actual algorithm is basically if greater than the last one, add delta. If not, do nothing. So for I in range length of target, we're actually gonna initialize this to be target of 0. We're always gonna have to add that first one. And if target of I is greater than target of I minus 1, we're gonna add the difference between target of I minus target of I minus 1, and then makes sense. Alright, let's take a look. Okay. Fire. How long did that take me? This was actually pretty easy, I feel like. Alright, 10 minutes. But I also did see this problem before, so Loki doesn't really count. And it has like a high acceptance rate, so let's see the discussion though. Yeah, I think most people agree this is pretty much a medium. Alright, I could probably do this one tomorrow. That's tomorrow's daily. Let's talk about the segment tree solution though. Can you solve with a segment tree? For the segment tree solution, what would you actually be doing? The minimum range can be obtained. I guess you can find with this segment tree, can you find where the minimum range is? Oh, you can. Yeah, for each range, you could very easily query what number is the smallest in that range. That's like the classic segment tree implementation, and then you'll just add the operations by that. But then you also have to like update your tree, I'm pretty sure, because after you add the operations to it, it won't be the minimum anymore, right? In that range, because it becomes 0. Not so sure on that, maybe I'm incorrect. Right. Sounds like that's it though.